Hello and welcome to Measurement in Intermediate and Senior Phase Mathematics, MAE103L, that is our module code. I am Mr. Ngoveni, your primary lecturer and your host for today. All right, I'm gonna take you through an overview of this module. What is it that we'll be doing throughout the year, right? And I'm very much hopeful that you will find this module both interesting and rewarding. As a primary lecturer, I'm gonna do my level best to assist you and see you through to your completion of this module. These are some of the activities that we'll engage in ensuring that that objective is achieved. We'll have lessons on the lesson tools that is in your module website. When you go to your module website, you're gonna find these lessons. So each time you need to visit this site so that you can see if there is anything that we have added here. We're gonna be using the discussion forum. We'll also record more videos. That is, you will have feedback of your assignment 2. You will have preparation for your exams just before you write your exams, right? We'll also have a WhatsApp group, which has proven to be quite helpful in the past. So basically, this is what we'll be engaged in, right? And before we go any further, I want to remind every student your My Life UNISA email address regularly. And when you receive emails there, don't ignore them. Go through them and see if there is no urgent issue that seeks your attention. So please make it a routine. Make it a routine, always go through this email address. And when you make any communication or contact with the university, with me, always use this email address. And I'm not only referring to this module, even with other modules. All right, if you can manage to do that, we will eliminate issues such as when you submit your exam, it end up not reaching us because you used your personal email. So this is an important issue. Take note of it. Right. Here are the due dates of your assignments, including the unique numbers. Assignment 1 is due on the 13th of May. And I've seen more students have submitted assignment 1. Hence, in today's presentation, I want focus on assignment 1. Right, assignment 2 is due on the 20th of July 2021, and its unit number is 852262. Okay. In this assignment too, I'm not gonna go through all the questions. I've selected a few questions based on may we pause? I've chosen some of the questions that have always given our students challenges in the past. So I will not be going through all the questions, and even with those questions, I will be explaining how can you should you approach those questions. All right, the first one, 1.2, it says construct a special angle 45 degrees without using a protector. To answer this question, I advise that you visit any senior phase mathematics textbook, all right, and check how do they draw these special angles without using a protector. You can also watch videos on YouTube, all right, and see how do they construct these angles. All right, so that is it. The construction of special angles is done in senior phase. You can borrow grade 9 textbook, any grade 9 textbook, this is explained there. All right, let's go to the next question. 1.7. This question we always we posing. I think is where we're talking about the relationship between the circumference and the diameter. All right. Here, 1.7.1 says, describe how you would find the circumference of a round object. For an example, a tin. Okay, you're required to explain how you find that circumference. All right. The second one, 1.7.2, find at least 4 round objects. After finding these 4 round objects, measure their diameters, meaning you need to find those objects, do this measurement of the diameter, and what would you do with this measurement? You will record it on the table there. So in short, 1.7.2 and 1.7.3, you can treat them as one, okay? So in this case, the marks will be allocated for 1.7.21, 1.7.2, because you're finding 4 objects, right? We're not gonna allocate marks for this one. We're allocating marks for measuring of the diameter and recording the measurement on the table. The next question, measure their circumference and record your measurement in the table. Because this question has been asked already, I'm not gonna attempt to answer it. Question is 1.7.1. describe how you would find the circumference of a round object. With me here, I've got that example. We're talking about this circumference. So you're going to explain to us how would you find that circumference, okay? How would you explain this to your learners? How would you and your learners measure the circumference, right? The second question is find at least 4 objects. I've got 1. You're gonna find 4. With these 4 objects, you're going to measure the diameter. I'm going to measure the diameter here, right? I'm finding 72 millimeters, 73, 75, 74. That means the diameter here is 75 millimeters. I'm going to repeat this. When you go through your diameter, going through the diameter, when you measure it, Mr. Sibotoma, may you confirm? Okay. Is to measure your diameter. Remember, when you are down there, you check how many millimeters there. You proceed, and when you get there, you find 75. You go down 74, 73. That means 75 is your diameter. So you take the longest length there. Okay. So we have the diameter of this object. You will record it there. You find a different object, a round object again. You do the same. You go through there and find the longest, measure there. Then you take it as your diameter. You record there. After that, you go to a circumference. Circumference is what you were supposed to explain in 1.7.1. After finding the circumference, you will record there. All right. Number 1, for the first object, remember the first object, you find the diameter. After the diameter, you go to the circumference. After the circumference, you will now say my diameter divided by the circumference is equals to how much? You record there. You do the same with other 3 different round objects. Remember, they must be different. Okay. Right. After that, after recording, you will now tell us what is it that you notice. What do you notice after recording all those measurements and dividing the circumference by the diameter? What is it that you notice? Okay, you make your conclusion. All right. That is it with 1.7. Let's go to 2.4. In 2.4, the question there is calculate the weight of a dog on Earth and on the moon if it has a mass of 28 kilograms. So here, what is important is to note that we are given mass which is 28 kilograms. All right. What is the formula for calculating weight? The formula for calculating weight is given by W equals to the force, which is equals to mass multiplied by acceleration of gravity, or in simple terms, gravitational force, right? The weight is equals to the force, yes. Because of that, weight is measured in newtons, all right? Mass is given in this regard, it is 28 kilograms, all right? So we should worry about the acceleration of gravity or the gravitational force, okay? The gravitational force will always vary depending on the location, that is, at which planet are we calculating the weight. All right. So in short, the gravitational force on Earth will be different from the gravitational force on the moon. Okay. Let me repeat this. The gravitational force on Earth and the moon are different. They are not the same. Okay. So it means you're going to do your research and find out what is the gravitational force on Earth, and then proceed and do your research to say, what is the gravitational force where? On the moon. Okay. The rest, I think it should not be a problem because you only have to substitute your mass is 28 there multiplied by the gravitational force that you shall have discovered. Right. In this question, in the question that regards the area and the arc length of a sector, I decided to take something that is equivalent to what is in your assignment. I didn't want to take exactly what is in your assignment because I didn't want to give you answers. So I took these questions from previous papers. So I'm going to explain them, and with that explanation, it will assist you to answer what is in your assignment. All right, let's start. I started there by giving the area of a sector. All right, what is area of a sector? Area of a sector is equals to theta over 360 degrees pi radius squared, where theta is in degrees. So when theta is in degrees, we use this formula to calculate our area. But when theta is in radians, we use the formula A equals to half r squared theta, or r squared theta all over 2. The two are one and the same. The same thing applies to the arc length. To calculate the arc length, if the angle theta is given in degrees, we use the formula theta over 360 degrees multiplied by 2 pi r. Okay. And when you find a formula that says arc length is equals to theta over 180 degrees multiplied by pi r are exactly the same. Ne? So what I'm trying to indicate here is this can be simplified into, you can divide through there into 360, it goes 180 degrees. That means we can write this formula as theta over 180 degrees multiplied by pi r. So the formula theta over 360 degrees multiplied by 2 pi r is the same as theta over 180 multiplied by pi r. I hope I made myself clear there. Now, when the angle is given in radians, the arc length is theta multiplied by the radius. All right. So here, that we given the diagram there. We given the diagram there where the radius is 7 centimeters and the angle of that sector is 80 degrees. Okay, calculate the angle of the minor sector in radians. The angle of the minor sector in radians. To find the angle, which is 80 degrees in radians, down there I have given you two options. The first one is when you're converting from degrees to radians, which is what is applicable here. So you will multiply 80 degrees by pi over 180 degrees. Simplify it and write down your answer. Okay. Now, if you were given an angle in radians and you're supposed to convert it to degrees, you will then multiply it by 180 degrees over pi multiplied by that particular angle. Back to our question. We have learned how to convert between radians and degree. Now, the next question says, calculate the area of the minor sector. To find the area of the minor sector, this is the minor sector because if we can complete this circle, the remaining piece there will be the major one. We've got the major, we also have the minor. So in our case, we're looking for the minor, the area of this minor segment, the minor sector, not segment. All right, to find the area there, we're going to choose between the two formulas. It's either we use the first one or we use the second one. And we're not worried this time because we have calculated our angle in radians. We have converted this angle 80 degrees in radians in the first question. So it means any formula there will do just fine. Okay. So if you choose the first one there, A equals to theta over 360 degrees pi r squared. It means you're going to use the angle in degrees, which is 80 degrees. So where there is theta, you're going to put 80 degrees. There is r, you're going to put 7. Then use a calculator to find the answer there. You will do the same thing if you were to choose the second one. You will say the angle that you calculated there in 1.1, you take it there, you put it there, and then here you'll put 7, and then you use your calculator, you find the answer. Okay, let's go to 1.3. Calculate the arc length of the minor. What is the length there? So the arc length is given by theta over 360 multiplied by 2 pi r when theta is in degrees. And arc length is theta multiplied by the radius when the angle is radians. So you are again going to choose any of the two because you have the angle in degrees, the given one, and the angle in radians, the calculated one in 1.1. So you substitute and use your calculator, go straight to the answer. All right, calculate the area of the major sector. Calculate the area of the major sector. What is the area of the major sector? Now, to find the area of the major sector, you can either say the area of a circle. Area of a circle is given by pi r squared. You substitute your radius by 7. You find your area there, and then subtract the area of the minor sector, which you calculated in the previous question. All right, or you can go and use any of the two formulas, but you need to mind one thing with referring to area of the major sector. And the angle that we are given there is not the angle of the major sector. This is the angle of the minor sector, meaning we still have to find the angle of the major sector, which is 360 degrees. 360 degrees. Remember the whole angle there all around is 360 minus 80 degrees, okay, which is 280. So the angle of the major sector is 280 degrees. Because we have the angle in degrees, we can use this formula, all right, and say where there is theta, you're going to put 280 degrees multiplied by pi multiplied by r. Our r is 7 squared, which is equals to, you give your final answer there. All right, next, calculate the area of the major sector. Oh, that was the last one. That was the last one. So that is it with questions involving sectors. Let's now move to the next one. Cans of fish are often packed in boxes as shown below. Calculate the radius of each can in the above box. Calculate the radius of each can in the above box. So to calculate the radius of each can, I'm going to use the very same can, right? To say this can, suppose this can is the one that will be fitted in the box there. And meaning one side that is the side that is 8 centimeters long will fit 2 of them. All right. A side, the first side, the side that we're facing will fit 2, while the side, the length there will fit how many? 1, 2, 3, 4, 5. Is it 5? Yes, it is 5. So on the other side, it is 5. On the other side, it is 2. Right. So now take the one that is 8 centimeters long. To say, on this side, I've got, it is 8 centimeters. So if I were to cause, I want to find an extra one side that is 8 centimeters long. We then say we've got 2 cans on that side, right? That means that will be 8 centimeters, all right? If this is 8 centimeters, it therefore means one of the 2, if this is 8 centimeters long, it therefore means one of them, each of them will be how much? 4 centimeters plus 4 centimeters, which will give us 8 centimeters. All right. So what is this 8 centimeters? This 8 centimeters is our diameter. So already we have a diameter. So having a diameter, what do we need to do to find our radius? To find our radius, we're going to divide the diameter by 2, meaning to find our radius, we're going to divide 4 by 2. That is, our radius is 2 centimeters. All right. Say we picked the other side. All right. If we picked, in case we picked the other side that is 20 centimeters long, we'll be having 2, 4, 5, that is 5, meaning 20 centimeters. I'm trying to check on 20 centimeters there, divide by how many cans along there? 5 cans, meaning we'll say 5 cans should fit along the 20 centimeter line, and therefore we must divide 20 centimeters by 5. Okay. Dividing 20 centimeters by 5, we get how much? We get 4. 20 divided by 5 is 4. This 4 is our diameter again. After getting the diameter, we then divide our diameter by 2 to get the radius. Remember, the radius is from the center to anywhere in the circumference. Okay. So that is how we find our radius. We pick a side and note its size, and then divide the size of that side with the number of cans in that particular side to get the diameter of each can. Now, from there, because you'll be having the diameter, you divide that diameter by 2. Let's proceed to the next question. The next question is calculate the area of the base of the box that is wasted. Right. Unfortunately, with round objects, when they fit in a box, they will always leave out space. I'm referring to that space in between there. So we become interested in knowing how much space is wasted in between, right? And to find that the area of that space, we do calculate the area of the box, the whole box at the base, and subtract the area of the cans. How many cans do we have? 2, 4, 6, 8, 10. We've got 10 cans, meaning we're going to find the area of one can and multiply that area by the number of cans, which is 10. And then subtract that amount from the area of the box. That will give us the area that is wasted at the base. Okay. Now calculate the volume of the box that is not taken up by the cans if the height is 5 centimeters. Given that the height is 5 centimeters, what is the volume that is wasted? Right. If you want to do it the hard way, it's fine. You say volume of the box. What is the volume of the box? You find the volume of the box, that is 8 times 20 times 5. That is area of the base multiplied by the perpendicular height. What is that volume? From that volume, you will subtract the volume of cans. So you will find the volume of one can, which is given by the formula pi r squared multiplied by the height, which is 5 in our case. You use that formula, you find the volume of one can. But you're not interested in the volume for one can. How many cans do we have? We've got 10 cans. So you're gonna say the volume of the box minus the volume of all the cans, right? And I said that is the hardest way. The easiest way will be to say, I have the area at the base. And I've got the wasted area at the base. And always when you're looking for volume, we multiply volume of a right prism, we multiply the area at the base by the perpendicular height. So in our case, we have the area at the base, which is wasted, that we calculated in question 2, but we can calculate again. It is 8. No, it cannot be 8. It is the area after subtracting the 2, we shall have received that area. So the answer to number 2, we're going to multiply it by 5, because the answer to number 2 is the area at the wasted, is the wasted area at the base. We multiply it by the perpendicular height, which is 5 centimeters, to get the volume that is wasted or not taken. Okay. That is it. We I'm looking forward to communicating with you. I know some of you have started communicating with me. We'll be setting up WhatsApp groups. We'll communicate there, and we'll also engage each other in the discussion forum. So if you have got any burning issue, feel free to drop an email. If I cannot assist you, I'll forward your email to the relevant people who can assist you. All right, so help is always available. So don't sit back and say, oh, nothing is gonna happen. So we are here to assist you. We are here to assist you. That is the main reason we are here. We are here for you. So make use of the opportunity that you have. You've got my number, you've got my email address. Talk to me there. All right. So I'll be setting up those email address. I'll be setting up those WhatsApp groups very soon. So we'll communicate there. I thank you so much.